The angle at the circumference, in a semicircle, is a right angle.
This clip is demonstrating another rule about angles inside circles. In the diagram here, AC is a diameter, it goes right through the center, and being a diameter it cuts the whole circle into two semicircles. Now, B is an angle drawn from A and C and is inside one of the semicircles. And I can move it around. I can put it into the other semicircle and move it around like that. The rule is quite simple. Quite easy to remember, this one. Whenever you draw an angle like this inside a semicircle, it's always 90 degrees. Wherever you draw it, and even if you move the diameter, it's always 90 degrees. So, the rule you need to remember is this one. The angle in a semicircle is a right angle.
Remember, a semicircle is half a circle. So, for looking at this, we're going to have an angle in a semicircle, and all that means is that our circle is split in half by a diameter, and then from each end of that diameter we create a triangle. So our whole triangle is within half a circle. That's why it's called the angle in a semicircle theorem. And all the theorem says is that if we have this, if we have a diameter, then that diameter is the hypotenuse of a right angled triangle. So up there we have a right angle. And no matter what the triangle looks like, if we have a diameter, the angle opposite is always a right angle. So we could have our diameter going through here, and it could be that this one's quite low down there, and then we have a longer side down there. But as long as we have a diameter in our triangle, this one here is a right angle. And that's what the angle in a semicircle theorem says. It says the angle in a semicircle is always a right angle. And what that means is if there is any diameter in a circle, so it goes through the center, then the triangle, any triangle created from that, the angle opposite it is 90 degrees. So let's have a quick look at a couple of examples. In this one here, we see we have a diameter going through here because it goes through the center. That's really important. It goes through the center there. If the center is not marked, it doesn't show that it is going through the center, then you cannot assume that it is just because it might look like it. It must have either the center marked by a point or possibly labeled as the center. The other way is it might have the line labelled AB, and it might say that AB is a diameter. That would also be enough information to tell you that this is diameter, and we're using the semicircle theorem. Because it's a semicircle, we know that angle up there is 90 degrees. So now we know that the three angles, 53, 90 and x, add up to 180. And that gives us an answer that x is equal to 37 degrees. This one is similar. We have a diameter going through here because it goes through the center once again, which means that this angle here is 90 degrees. This time we've got a bit of algebra, but we know that 2x, this one, plus x, here's this one, plus 90, which is that one, is equal to 180 degrees. So we have 3x plus 90 equals 180 degrees. So 3x equals 90, so x equals 30 degrees. And that is how we use the angle in a semicircle theorem to find the angle is 90 degrees and find other angles in the triangle.